Welcome back to another Python tutorial. We're continuing our discussion on linked lists, so one of our data structures. Previous video, what did we cover? Well, we talked about how to insert data into our linked list. And so initially on the first video, we just showed how to insert in the front. We expanded that to say, well, what if we want to insert in the end? Or what if we want to insert in the middle? Or something along that nature. This is where we can kind of make this linked list a little bit more dynamic. So very useful. We also talked about how to traverse a list. That means printing out all the values or, just iterating basically through that particular list. We also discussed how to get the list size. In these two situations, what is really in common? Well, if you noticed here, we are traversing the entire linked list. And so basically in these situations, it's going to be the entire length of the list. So if there's 5 elements, it's going to, be O to, basically it's O to the n. It's going to be linear because in each one of these situations, we have to traverse the entire list. And if you also notice, I did write each one of these a little slightly different. You'll notice that, again, there's different ways to write each way of doing it. I'm not going to tell you which way is necessarily better or worse. I'm just saying there are different ways to do it. You've got to kind of figure out what works best for you. So just keep that in mind. And then some other things about it is we talked about, again, the insertion. So if we're inserting at the end, well, that means we're going to have to traverse what? The entire list. So again, that's going to be a linear one. Basically with the head one, that's a little bit quicker, but that's regardless. And then insert middle, again, it's constant time insertion because, again, in that situation, we basically we're passing through the node and we're just changing where it's pointing to. So we're not actually traversing the list. We're already at the point we need to be. We're just changing where that point is pointing to. So good things to keep in mind when you're actually looking at the linked list and trying to understand kind of what's going on. All right, so what are we going to cover next? Well, we're going to talk about deleting nodes, so deleting specific values from our list. And then we're also going to talk about deleting the list itself and then searching the list. So let's start with the first one. Delete node. All right, so that's going to take the linked list itself and a value that we're going to try to find and delete. We're going to find out that this is very, very similar to searching. Okay, so the current node will equal self.head, so the first node. Found will equal false. That'll make a little bit more sense when we get to it. Previous node will equal none at this point because right now we're starting at the beginning, so there's nothing behind us. Okay, so first thing we need to do is if the head node is none, then we can just exit early. Basically, that means there's nothing in our list. So if the current node is equal to none, then return. So basically just leave the function because if there's nothing in the head, that means we don't really have anything in the list. Next, while the current node does not equal none and found is false, so 2 conditions have to be met for us to exit this while loop. The node has to be none and found has to be false. If the current node dot data equals the value, what's going to happen? Well, found, we'll change that to true, and then we'll break. Else, what we're going to do is we're going to say the previous node will equal the current node, so the node that we're currently on, and then the current node will equal the current node, and then we'll call the getNext method. And I have 3 R's here, which doesn't make a lot of sense. And so before we go on to the next part, let's kind of just look through this again. So we've defined the current node to be the beginning node. If found is false, that's just kind of setting us up when we're going through our while loop. And then the previous node, so that means basically if we don't find it on the first one, then we're going to have to keep the previous one there. And then we're going to have to handle the situation where the current node basically has nothing in it. And if there's nothing in the current node, when we've defined it up here as being the head, basically that means the list is empty. And so what we're going to do is we're going to keep looping through. We're going to traverse the list, and we will only keep traversing the list on two conditions. So both conditions have to be met in order to keep traversing. The current node cannot equal none, so that basically means we cannot have reached the end of our list. And found has to be false. So that means if found is true, it means we found the value, so we can exit the while loop. The other condition, again, where we can exit is the current node equals none, which means we've reached the end of our list. So those are the two conditions that have to be met in order to keep looping or traversing this particular list. And as long as those two conditions are met, then the first question we're going to ask is, does the current node, does the data portion of that node, does the value equal the value that we're looking for? If it is, then set found equal to true and break the while loop. And then else, set the previous node to the current node, so the one that we just traversed, and then the current node is going to equal that current node that we were just on, but the next one after it. So after that, what's the outcome? Well, there could be an outcome that the node that we were, basically the value we were looking for, never existed. So if the current node is none, basically that means we reached the end of our list and we never found a value. Raise value error, and then say something like data not in list. So basically we traversed the list. There was nothing in there that matched the value that you passed through to us. So basically we're telling you we never found anything. Now let's move on basically to the next part. So if it was found, then we need to delete it. And so the first thing that we're going to do is we're going to say if the previous node is none, what we're going to do is we're going to say self.head equals the current node called get next. And so basically it means we found it on the first one, basically. And then from here, else the previous node, what we're going to do is we're going to set the next one equal to the current node, and then after calling the get next method. So what are we doing here? This is the portion where we delete it. And so if the head node contains value, jump it and set that equal to the node basically after the current one. And so in this situation, it means we found it on the first iteration. So basically it was the first value in the list. So really what we're going to do is we're going to say, hey, the new head is the node after the old head. Otherwise, take the previous node and then set the node that comes after that previous node equal to the current node that we're on. Basically what we're doing in a sense is if this was the node that we were looking for, what we would do is we would say, well, instead of pointing to this one, just point now to this one. So that's kind of the neat thing about it. We're just changing where it's pointing. So it's basically deleting it in a sense because it's no longer going to be able to point to it. So we're no longer pointing to it in that memory location. We're saying, hey, go around it and just go to the next node. So really here is if it was the head, set the new head equal to the node after the old head. Otherwise, take the previous node and set the node after it to be the one that contains the value and comes after it. Hopefully that makes sense. All we're doing is we're jumping the node that has the value. So this is probably a little bit more of one of the complex ones, but basically first condition is there's nothing in the list, so just jump out early. Otherwise, if the current node is none, if the current node doesn't equal none and found is false, we're going to traverse the list. If we found it, then we change found equal to true and we break out. And then we need to also do the situation, which basically means we traverse the entire list and it wasn't in there. So in that situation, we got to let the person know, hey, the data basically wasn't in the list. If it was found, then we can move on to the deletion. And so the first thing would be, well, we found it in the head value. In that situation, we're just going to change where the head is pointing to. Otherwise, we're going to take the previous node and have it point to the node after the one that contains the value. And so what is that going to look like? Well, let's take a look. Alrighty. So we'll say linked list delete node, and we'll say 90. And we will say linked list dot traverse. All right, and then I'm gonna just break this out so you guys can see it just a tiny bit easier. What happened? Did I not do it again? I keep doing it. Okay, so we can see here that it deleted the 90 from the linked list. So it found the value and basically something happened. Well, what happens if it was, 37? Then it releases the 37. What happens if I put in something like 100, right? We got a value error. Data not in list. So it was able to handle the situation where, hey, the value you're looking for isn't in the list. And so that does come in handy. Okay, so now that we've seen how to delete a node, we're going to talk about actually searching the list. And so you're going to say, Alex, this looks almost identical. That's great. That makes our lives easier. Okay, and with this one, what we're going to do is we're going to say define search list. Find search list. It's going to take the list itself and then a value that we're searching for. There could be a situation. What happens if our value appears more than once? This might be a problem. It's not really a big problem, but we'll see that we can handle that. Okay, so what we'll do is we'll copy this. Again, make our lives a little bit easier and just save a little bit of typing. So we'll say current node is equal to the head, and then the previous node is still none. And then we're going to say something like result list, right? And so this will just actually be a list of items. And what we're going to do is, again, the situation where, hey, if current node is none, that means you basically you don't have anything in your list. So there's really nothing to look for. So that's kind of the easy way out, as I call it. It's like, hey, that's kind of a good situation in a sense because basically we don't have to do anything. So what we're going to say is while current node does not equal none, we're going to do some stuff. Well, what we're going to do first is we're going to say if the current node dot data, so if the node that we're on, the piece of data in it, if it equals the value that we're looking for, then take the result list, we will append the current node. And then the previous node will equal the current node. And then the current node will equal the current node, get next. And then the else component will be the previous node. So if it's not found, well, the previous node will just simply equal the current node. And then the current node will equal the current node get next. And so really these two are almost identical. It's just in this one we're appending it to the result list. And so what this is going to look like is we will now return result list. So we have the first node, the previous node, and the result list. In the situation where the current node is none, so basically the head value is none, means there's nothing in the list. Otherwise, traverse the list until you reach the end. And if the node that you're currently on, if the value in that node equals the value that you're looking for, well, then append that current node to the result list. And then change the previous node to the current node, and then set the current node equal to the current node get next. I guess really you don't really have to have the previous node in there, but regardless. It's good for, I guess, in a certain sense. I think I copied that from another section. I'll try it out in a second, see what it gets us. Okay, so let's do this. We'll do linked list, search list. I will put in another 37 just to see if it comes back with more than one. And then we can see, oh, it's because I delete it here. So now it has 2. That's great. So it found it in both situations. What if I put in 100? Basically returns an empty list. What if I do here? And then what we will do, and then if I do 37, yeah, I don't know why I had previous node in there. Apparently, I probably copied it from somewhere else. But yeah, you don't technically need to have it in there. You can just have the current node. Basically, what you're doing is you're just traversing the entire list like we were doing before. So again, this is just another example. You're basically iterating over it. And really, too, I mean, in a sense, you could almost use this, and if this is returning a value back to you, you know, that's one way to do it as well. So again, different ways, not necessarily a right or a wrong way. Hopefully, though, you are kind of noticing this is pretty similar. I mean, it's not identical, but it is similar. So, it can definitely help. For the most part, I mean, it's pretty much identical. All right, so now that we've talked about that, we've deleted a node, we've searched the list. Let's talk about deleting the list. What if we want to delete the list? Well, that takes the list itself. Oh, lordy. We need to start from the beginning, and that will, again, be the current node. That will be equal to self.head, so the head of the linked list, and we'll say while current. Again, notice I changed it a little bit up here. Or sorry, right here. Just different ways of writing it, not necessarily wrong or right way. And what we'll do is we'll say grab the next node. Next node. And then we'll say next node is equal to the current node. And then in this example, instead of doing get next, I'll just call the next node property. And then what we'll do is we'll delete the current node. So we'll say delete current.data. So basically, in a sense, almost like clearing it. We will also set the current equal to the next node. And so we'll say current node. And I don't know why I said current. It's current node is equal to the next node. So let's see what we get. Linked list, delete list. And then if I do linked list, if I do head, it should return data. We should return none. So basically, it cleared that that data value from the linked list. So kind of useful if you want to delete the values from a list. That's one way to do it. So, God, what have we done so far? I feel like we've done a lot. Yeah, that's enough. Okay, so I'll cut it off here. I'm trying to keep them under 20 minutes. So if you have any questions, what did we cover? Well, we talked about deleting the node, searching the list, and deleting the list itself. So if you have any questions on those particular topics, please put them down in the comments below, and I will try to get back to you. Also, if you could, please make sure to like the video. We always appreciate the support. And if you're not already, please make sure to subscribe to the channel so that way you get regular updates as we explore, different topics, different data structures. And then also, if you are somebody who is studying right now and, you've watched a couple of these videos in a row, give yourself a break. I mean, I know some people like to watch every single one right after that. Don't do that. Just take a break and then you can come back to it, right? That way you give yourself some time to digest the material because, last thing you want to do is, try to cram everything in, because if you're like me, cramming doesn't work. It just comes back to bite you in a way that's not so good. And then also, like I said in the first video, go explore other topics in the sense of like read papers on it. I'm going to try to provide some, links down below and on the GitHub repo where, you can find some resources. Because again, I get it. Some people have to hear it different way, or they have to see it written different ways to kind of understand the concept. Do what works for you. If you understand after this video, that's awesome. If you don't worry, you'll get it. You just got to look at different ways and just literally keep repeating, and eventually it will stick. I promise. It's the nice thing. We look at it enough times, it definitely sticks. So thanks again for watching, everybody. We'll see you in the next video. Thanks again.